Good morning everyone. I am Priyanka. I am currently pursuing BTech first year in Cse-D. Today I want to present a small topic on find the minimum value of x square plus y square plus z square if xyz equals to a cube. Now move on to the topic. Significance of optimization in mathematics. The problem of finding the minimum value of x square plus y square plus z square given the constraint xyz equals to a cube is a classic example of constraint optimization. This type of optimization is critical in various fields such as economics, engineering and physics where resources are limited and trade-offs are necessary. In this problem, the main goal is to minimize the sum of squares of the variables while adhering to a specific product in this problem. This demonstrates how to effectively use mathematical tools to achieve optimal solutions in real-world scenarios. By employing Lagrange's multipliers, we can transform this constraint problem into a solvable format, allowing us to derive the minimum value systematically. Understanding this method do not enhances problem solving skills but also provides insights into the power of mathematical reasoning in optimization. Now move on to the constraints. Variables is xyz and the constant is xyz equals to a cube, and the goal is to prove minimize xyz equals to x square plus y square plus z square, and the method preview is use Lagrange's multipliers for occurs optimization with constraints. Lagrange's multipliers allow us to find extreme values of functions subject to constraints. Here's a breakdown of the concept. Purpose is solve optimization problems where an objective function is subject to one or more constraints. Method introduce a multiplier that incorporates the constraint into the objective function. Lagrangian function is formulated as L is equals to f of xyz minus lambda of g of xyz minus c. Procedures differentiate the Lagrangian with respect to each variable and the multiplier. Set partial derivatives equal to 0 to find stationary points. Solve the resulting system of equations for the variables. Benefits: simplifies the problem by converting a constrained optimization problem into an unconstrained one, providing a systematic method for finding optimal solution. The Lagrangian function represents a crucial step in constraint optimization. Here's how it's formulated for our problem. Lagrangian definition: L is equals to f of xyz minus lambda of g of xyz minus c. Objective function is f of xyz is equals to x square plus y square plus z square. Constraint function g of x comma y comma z is equals to xyz minus a cube equals to 0. Lagrangian multiplier: lambda acts as a scale factor to adjust the influence of the constant on the objective function. Step-by-step approach: identify the objective function and constraint, construct the Lagrangian by combining both functions with the multiplier, compute the partial derivatives of L with respect to x, y, z and lambda, set each partial derivative equal to 0 to establish a system of equations. This method transforms our constrained problem into a manageable form, guiding us toward the minimum form of our objective function while adhering to the specified constraint. Defining the objective and constraint functions. In our optimization problem, we need to define our objective function and constraint function clearly. Objective function is f of xyz is equals to x square plus y square plus z square. This function represents the sum of the squares of the variables we aim to minimize. Constraint function g of xyz is equals to xyz minus a cube is equals to 0. This constraint expresses the condition that the product of the variables must equal a cube. To find the minimum value of x square plus y square plus z square using Lagrange's multipliers, we first define our Lagrangian function. L is equals to x square plus y square plus z square minus lambda of xyz minus a cube. The next step involves calculating the partial derivatives of the Lagrangian with respect to each variable and the multiplier. Dou L by dou x is equals to 2x minus lambda yz. Dou L by dou y is equals to 2y minus lambda xz. Dou L by dou z is equals to 2z minus lambda xy. Dou L by dou lambda is equals to xyz minus a cube. To find the minimum value of the function using Lagrange's multipliers, we start by calculating the partial derivatives of the Lagrangian. Now calculate dou L by dou x. Set the equation as 2x minus lambda yz is equals to 0 and rearranging gives 2x is equals to lambda yz. Calculate by dou L by dou y. Set the equation 2y minus lambda xz is equals to 0 and rearranging gives 2y is equals to lambda xz, and calculate dou L by dou z. Rearranging gives dou z is equals to lambda xy. To derive the relationships between x, y, z, we begin by analyzing the equations obtaining from setting from the partial derivatives to 0. From dou L by dou x is equals to 2x minus lambda yz equals to 0, we have 2x is equals to lambda yz. From dou L by dou y is equals to 2y minus lambda xz is equals to 0, we find 2y is equals to lambda xz. From dou L by dou z is equals to 2z minus lambda xy is equals to 0, we find 2z is equals to lambda xy. Dividing the first two equations, it gives x is equals to z. Similarly, dividing the second and third equation, it gives y is equals to z. From these relationships, we can conclude x equals to y is equals to z. To find the minimum value of x square plus y square plus z square, we utilize the relationship established by the constant xyz is equals to a cube. Given that we derived x equals to y is equals to z, we can substitute this into the constant. From x, y, z is equals to a cube. Substituting gives us x into x into x, where x into x into x gives x cube, and final answer is xyz is equals to 3a square. The minimum value of x square plus y square plus z square under the given constant is minimum value is 3a square. To verify the result, we can consider the nature of the function. Each variable's contribution to the sum of the squares increases as they deviate from the values of x equals to y is equals to z is equals to a, reinforcing that the minimum values at this point occurs due to symmetry and equality. Thank you.